In this video, we're going to continue our analysis of logarithmic equations. Just now, we're going to focus on solving. In order to solve, we do have to keep in mind that we have to convert between logarithmic and exponential form. So logarithmic form, p equals log base b of n, will be converted to exponential form, which says your base to the power of p is equal to your value n. This is the key to the concept for this. So to solve, let's do that. Let's convert between them. So if I take a look, log base x, so x is my base, my power is 2, should be equal to 9. So x squared equals 9. So to solve this, well, you take the square root of both sides. Square root of x is x, square root of 9 is 3. And so my answer is x equals 3. Now, some of you maybe watch this video and think to yourself, Mr. Rainsberg, you told us before when you are solving an equation and you square root both sides, you need to take in consideration both the positive and the negative. You need to put a plus or minus sign, and that is true. However, I am ignoring the negative. And the reason why I can ignore the negative is the restriction that exists with logarithms. We learned in the first video in this series that your base for logarithms has to be greater than 0. It has to be, I wrote down, positive. And so that is why I am ignoring the negative when we are solving, is because I cannot have a negative base. I can only have a positive base. So you're right. When you square both sides, you do put the plus or minus. However, because of my restriction, I only care about the positive. Let's look at the second one. Log base 3x of 125 equals 3. So my base is 3x. My power is 3. So this whole object, 3x, is being raised to the third power. Put it into parentheses, and that should equal 125. And so now, how do I solve for x? Well, you could do your power rule if you want. What I'm going to do is I'm going to cancel out this third power right away. I am going to take the cube root of both sides. And what that's going to allow me to do is that's going to take the cube root and the cube and we'll cancel each other. And I'll only be left with 3x. And I know the cube root of 125 is just 5. And so x equals 5/3. And that's your answer. If you wanted to, you can skip this part of the video to go to the next example. Or what you could see is if you wanted to apply your power rule from this point, you could. The 3 goes to the third power goes to the 3, so 3 cubed is 27. X cubed equals 125. Divide by 27, so x cubed equals 125 over 27. And then cube root both sides. Cube root of 125 is 5. Cube root of 27 is 3. So either one of these techniques work. So now let's go on to the third example. Log base 8 of 3x minus 1 equals log base 8 of 2x squared. You notice something. There's the same logarithm on the left side and the right side for this. And so what I'm going to do is I'm just going to ignore it. If I have one log on the left and one log on the right, and that's it, log base 8 of some expression equals log base 8 of some expression. Well, those expressions need to be equivalent then. And so I have 3x minus 1 equals 2x squared. Now this is a quadratic. So to solve this, what I'm going to do is get all of my terms on one side. So I'm going to subtract the 3x and I'm going to add the 1. This is your AC method for factoring. So 2 times 1 is 2. You want two numbers to multiply to give you 2 and add to give you -3. That would be -2 and -1. So 0 equals 2x squared minus 2x minus 1x plus 1. We factor by grouping. So 2x times x minus 1. Factor out a -1 here. And then finish the factoring by group, and you have 2x minus 1 times x minus 1 equals 0. Set each one equal to 0 and solve. You get 2x minus 1 equals 0. You would add 1 and divide by 2, which is 1/2. You get x minus 1 equals 0. X is 1. And so I have two answers here, x equals 1/2 or x equals 1. And so this one, you can see factoring still comes into play for this. And in this concept, we learned that if you have one log equal to the same log and base, then the expressions have to be equal to each other for it.